Hey everyone, day 7, Math 133. Today we're going to cover the Chapter 4, Project 1. I might have said that we were also going to cover the cumulative review number 1 today. And that's not the case. I apologize for that. We're going to skip cumulative review number 1. Cumulative review number 1 covers Chapter 2 and 3. Um, and it is good practice if you are studying for the
Hey, Mom,
midterm. So feel free to
do you have any
work
pencils?
on that. Oh,
Oh, wait, never mind. I found mine.
yeah. So for the cumulative review number 1, like I said, we're going to skip that one. We are going to do cumulative review number 2 next week on Tuesday, and we are going to do cumulative review number 3. But yeah, today we're just going to cover Chapter 4, Project 1. Okay. The recording for the morning video is available. I'll be recording this evening as well, and hopefully put that one in there as well. Again, you only have to watch one of them. So sometimes I'll only put one in there. They're both the same information, so you don't have to watch both. Okay, you only need to watch one. Okay, so today we're going to click on Chapter 4, Project 1 in Canvas, exploring the correlation coefficient. Okay. And that's going to bring you here. There is a video that you can watch on how to do this assignment, but we're going to do this project together, so you don't have to watch that video. Okay. But we're going to click on the link where it says open the Google document at this link, and that's going to bring you to the Google document here. And I'll drop this in the chat so you don't have to go search for it. There we go. Okay, but you're not going to be able to put your answers in that because you have to do file, make a copy, right? And you don't have to rename it if you don't want to. That's fine. It's not fall 2024 anymore. It's spring 26. But again, like I said, you don't have to rename it if you don't want to. You do have to change where you put it. It can't go in that folder. It's got to go. You can do My Drive, or if you have a location where you're saving all of your uh, Math 133 documents, you can put it there. Just someplace, probably someplace where you'll be able to remember how to find it for when you're studying for the midterm, right? That might be helpful. Okay, so now that I've made a copy, should be able to edit it, right? There we go. There we go. All right, so today exploring the correlation coefficient. So we're going to let's see. Yeah, go ahead, Mike.
Mine, it is not allowing me today not to make a copy.
Oh, so make sure you change the folder. So if you do file, make a copy, make sure you don't try to save it in this folder, old projects not used anymore.
No, I mean it's
You're gonna,
the make a copy selection is grayed out.
oh, you're probably not signed into Google in that case. So make sure you sign into Google.
Oh,
Or are you already?
huh. I don't remember having to do that before.
Yeah. Yeah, Google, usually you stay signed in forever in Google, right? But uh anyway, hopefully that's what the issue is. If it's still not working for you, let me know. Okay. Okay, so today though, what we're gonna do, we are going to access a applet in StatCrunch. So we need to go log into StatCrunch and select applets, correlation by eye, and click compute. Okay. All right, so we're gonna go over to statcrunch.com, and up in the upper right corner, click sign in or register. Okay. Make sure you sign in. Once you've done that, this orange button in the middle is going to light up, and that's what we're going to click on today. We're going to click on Open StatCrunch. I think there's a way to get to it through the interactive applets, but we're not going to do that. We're going to click on this orange button for Open StatCrunch. Yeah, so it'll bring you here. Okay. So this is just a blank workspace in StatCrunch, okay? So what do we click on again? We click on Applets, correlation by eye, and click Compute. So in the upper left, applets, there's a couple of different applets here. Oh, there's games. All right. We're going to do correlation by eye. And we'll just hit compute. Okay. And it's going to give you a whole bunch of dots. Okay. So this dot, all these dots here, it's kind of like a game. So you can guess what the correlation coefficient is. So looking at this right here, if I drew a line through the middle of these dots, I'd probably draw a line like this. So that's going to be a negative correlation. So maybe I can guess, maybe it's a negative 0. I don't know, 0.6. And if you are within 0.1, you're right, you win. So check. Yeah, I got it. All right. So if I had said, 0.9, maybe it says, oh, try something lower. Okay. And then there's a show button where you can see the actual number. So I had said 0.6. I was within 0.1 of the correct answer, which was negative 0.7. Okay. That's not what we're doing. That's just if you're playing the game. Okay. But we definitely want to click on the show button here. Okay. So click on show so you can see what the correlation is. Okay. So these points on here, you can actually slide them around. You can see how it changes your correlation. If you slide them off the graph, you can actually get rid of them. So I had 20, now I have 19. I can get rid of some of these dots if I wanted to. You can put in a different number, like if you wanted 100 dots and then hit simulate, you get a whole bunch of dots. Okay. You can add points. The reset button gets you back to nothing. So, but we always want to make sure that we have the show button turned on. Okay. All right. So let's go back to our project though, and talk about what we're going to do. So we went to StatCrunch, signed in, applets, correlation by eye, and compute. Okay. And you're definitely going to have a different graph from me. Okay. Anytime we're working on the projects, you're going to have different stuff from what I have, right? You're going to have different answers. Like, I had looked at like carbon emissions one time, but you were looking at something else, okay? Or we were looking at like the mean, median, and mode, and I was looking at I don't know, I was looking at video games or something, but I said you can't use the same data set. Okay. All of the projects, you're going to have different answers from me. Now, the worksheets, though, that we work on in class, like the review worksheets, those ones you should have the same answer as me. But today is a project where you get to work on your own data, and you're going to have different numbers from what I have, which is totally fine. Okay, so what are we going to do, though? We're going to look at the correlation coefficient, and it needs to show in every graph. We're going to be copying a whole bunch of graphs into today's project, into today's document here, okay? Make sure that all of the graphs, though, I can see the correlation coefficient, okay? So question 1, positive association, create a scatter diagram of 12 to 15 observations with a moderate positive relationship. Okay, so 12 to 15 dots. So let's go back to StatCrunch, and we need 12 to 15 dots. So 12, 13, 14, 15, any of those is fine. I'm going to do 13, and I'm going to hit simulate. Okay, so my dots here are kind of all over the place. Okay, I need to click show down here so I can see my correlation coefficient. Okay, so make sure you have show turned on. And we want a moderate positive relationship. Okay, so looking at my correlation coefficient, what number do I need to see here to get a moderate positive correlation? What would be an example number? Right now I have 0.2013, which is not correct. I need to change that. Okay, so Rachel says 0.75. Yeah, 0.75, Raya says 0.6. Both of those would be good options for a moderate positive correlation. So on page 255 in your course pack, in the exam notes packet, this page 255, is all about chapter 4. It's all about linear regression. And there's a graph right here. There's a line chart that shows if you have a specific correlation coefficient, what is the relationship that you have. So I need a number between 0.5 and 0.8 to have a moderate positive correlation coefficient, okay? All right, so that's what I'm aiming for. So 0.5, 0.6, 0.7. It can't go above 0.8, okay? Because then I'd have a strong positive. But, 0.75, like you said, that one's fine, Rachel. So, all right, let's go back to what I have. And if you're lucky enough that you already have it, well, good job. But I don't. So moderate positive, I need my dots to kind of be going upward. So I kind of need to move them closer together like this. Okay. So now if I was going to draw a line through the middle of this data set, the line I would draw would go right here. Yes? I wouldn't draw it like this. There's no points up here. There's no points down here. Okay. So this has a correlation coefficient of 0.69. 0.69 does land in this range. So this is good. Okay. So we'll grab a screenshot of my graph. Okay. When you grab that screenshot, make sure you can see the correlation coefficient, right? So if I was going to draw a line through these, the line would probably look something like this. Yes? We're not going to draw the line. We're just going to put it into our project here. So right there. All right, there we go. We got our moderate positive correlation, okay? All right, question B, move some of the observations around to make a weak positive relationship. So before I go on, I'm curious, what correlations did you guys get? I had 0.69. What did you guys get on yours? 0.7 sounds good. 0.77, 0.79. So Gabby, yours was 0.1675. Now it's going to be too low. 0.1675 is going to land right in here. And so you're going to want to, and so same thing, Jadalyn, yours is 0.36. You're going to want to move some of your dots around. Try to move them so that they're more like in line like this. Okay. Now, not like this though, because this correlation is too high, okay? I need a number that's somewhere between 0.5 and 0.8. So let's move some of these off of my line. There we go. So that would be fine. 0.68, okay? That's fine. Even 0.78 is fine, okay? But 0.36 is a little too low, okay? All right, so let's move on to question B. Move some of the observations from the scatter plot around to make a weak positive relationship. So what kind of number am I looking for if I want a weak positive relationship? Right, it says 0.4. Yeah. So weak positive would be any number between 0.3 and 0.5. So 0.4 is right in the middle, yes? So I want something around 0.4. Now, how do I do that? Let's go back over to StatCrunch. So I want to move some of these dots around. Now, right now, if I tried to draw a line through the middle, it would look like this, okay? If I move these closer to the line, it goes up. I don't want that, so I need to move them away from the middle. So let's move them around until we get something like 0.4, 0.3. So earlier, Jalen, you said you had 0.36. That would have been a good weak positive, okay? So now I have 0.44, so that's good, okay? So I think this is fine. So let me grab my snipping tool and I'll take another screenshot of this where my correlation coefficient is 0.4. Okay. And let's paste that into question B. Okay, so Jalen, 0.689, that's for your first one, that's good. Yep, you're good. Question C, move some of the observations from the scatter plot around to make a strong positive relationship. Okay. So a strong positive relationship would be something higher than 0.8. Okay. So yeah, like 0.9. Thank you, Rachel. Kelly says, so yours is saying that it's negative. Okay. If it's negative, that means your dots are pointed downward like this. See, if my dots are pointed downward like this, then I'm going to get a negative correlation. Okay. So I need to move them so they are pointed upward. Okay. So there we go. It doesn't have to be a perfectly straight line. Okay. And you're not going to be able to get it in a perfectly straight line, but that's fine. It just needs to be pointed upward. It doesn't have to be pointed like straight upward, just slightly upward. But you want a correlation around 0.8, 0.9. Okay. So mine, 0.9625. All right. So I'm going to grab a screenshot of that. And that is our strong positive correlation. Okay. All right. Question D. If you align all the points into a perfectly straight line with positive slope, what should be the value of the correlation coefficient? Rachel says it should be +1. I agree with that. Okay. Now, I'm not going to ask you to do that because that's going to be nearly impossible with this many points. You can probably do it with 3 points. Okay. So you don't need to, but if I only had 3 points here, I could probably get it to be 1. Let's see if I can pull it off. There we go. Right there. Okay. So that is a perfectly straight line. Okay. Now that's if you have 3 points. If you had 2 points, it's guaranteed to be a straight line. And oh, StatCrunch is not even going to let me do that. The sample size has to be between 2, so higher than 2 and less than 1,000. Okay. So, all right. So, Gabby, your question is 0.30 a good for the second one? Yes, it is. Okay. So let's go back over here. All right. So part 2, let's hit reset at the top. And now we're going to look at negative. Okay. So whether your correlation is positive or negative, so like right here I've got like positive 0.7. Okay, that's because if I drew a line, that slope is positive. If I slid this down just a little bit, now it jumps to negative 0.93. So, and that's because now if I drew a line, it's going to have a negative slope. Okay, so your correlation is going to have the same sign as whatever your slope is. If your line is going down, then it's negative. If the line is going up, it's positive. Now that doesn't mean that a negative correlation is bad. Actually, a negative correlation can still be a strong relationship. Okay. So an example of that would be if I asked, if I was looking at how many hours you exercise each week versus your weight. Okay. most people would agree that a high amount of exercise means you're going to weigh less, right? We still recognize that that is a strong correlation that diet, so like exercise and weight uh, are definitely related. Okay. Very little exercise, you're probably going to weigh more, like I do. Um, so uh, just because it's a negative slope doesn't mean that it's not still something that you can use and still something that you can predict. Okay. It just means that they have an inverse relationship is all. Okay. All right. So let's hit reset. Okay. Oh, nice. And let's do another 12 to 15 points. I'm going to do 14 this time. And I'll hit simulate and show. So it looks like I have a negative slope already on my graph, but it's too much, negative 0.91. I want a moderate negative. So moderate negative would be something between negative 0.8 and negative 0.5. So like negative 0.6, negative 0.7, somewhere in this range. Okay. So I need to move my points around until I get something in that range. Now, mine was too good of a straight line, so I need to actually screw up the points and get them off that line. So how about this? Negative 0.6. Is that good? Negative 0.6 would be right here. So that lands in the moderate negative range. Okay. And I'll copy that into question E. There you go. So once again, I'll pause right here for question E. What kind of correlation did you guys get for moderate negative? Mine's got negative 0.62. I like that one. So Crystal says 0.68. Now that's a positive. We want it to be negative. We want our line to be going downward. So you're going to need to move your dots around. Because right now, if I tried to draw a line through this, I don't think it would make sense to draw a line this way, right? There's no dots down here. There's no dots up here. If I drew a line through the middle of this data, it should look like this. Oh, Crystal, you just forgot your negative. Yeah, you're good then. Okay, so Kelly, yours is negative 0.42, and I think that's too low. So negative zero point 0.4 would land right here. So I think you need to make yours actually more on the line, Kelly does, to get into the negative zero point 0.5 region. Okay. Gabby, yours looks good. Jalen, yours looks good. Okay. All right, that was question E. Question F, move some of the observations around to make a weak negative relationship. So now weak negative, we do want to be in this negative 0.3 to 0.5 range. So now we do want it to be negative 0.4. So let's do that. So if I make them closer to the line, that's going to make my number get bigger. I don't want that. So I need them farther away from the line. So I got to move them away. So like that. Okay. So mine is negative 0.38. Okay. So Gabby, 0.29 is just a tiny, tiny bit too small because 0.29, where would that land? 0.29 would land right here. and you actually need it in this range. So you need to get a little bit over or a little bit smaller than the negative 0.3. So probably just need to move one dot closer to the line and you'll be fine. All right. Part G, move some of the observations from your scatter plot to make a strong negative relationship. So now, strong negative, we want something like negative 0.8, negative 0.9, okay? So for that, we need to make them like close to the line. Still pointed downward though, okay? All right, there we go. Negative 0.96, okay? That looks good. Yes? That's a strong negative. We'll paste that here. All right. Question H. If you align all the points into a perfectly straight line with negative slope, what should be the value of the correlation coefficient? Yeah, you guys got it. -1. Okay. -1 is perfect negative correlation. Okay. All right. Part 3. No association. So now we're going to hit reset again at the top. Okay. Create a scatter diagram of 12 to 15 observations, this time with no relationship. Okay. So let's go back over here to StatCrunch and we'll hit reset. And this time, so 12 to 15 points. So I'll do 12 points this time. And I'll hit simulate and I'll hit show. So this one I got a negative 0.58. So that's not what I'm looking for. No relationship is going to be somewhere in this range. So give me a number somewhere in this range. So 0.22 is good. Thank you, Kelly. What else? Negative 0.1 is good. Yeah, 0.11. Rachel. What number's right in the middle? What number's right here between negative 0.3 and positive 0.3? Right in the middle is 0. So I would like a number close to 0. Gabby's got one. 0.2 is good. The closer you are to 0, that means the less there's a linear relationship. So basically, I need to take all my points and just scatter them all over the place. Some up here, some over here, some down here. Just a hot mess is what I want. Okay. So now I've got 0.012. Okay. Yep. Quinn, yours is good. So you just want dots just all over the place. Okay. All right. So I'm going to grab that. Okay. So paste that in there. Yep. Yours looks good, Nathan. Okay. So what would be an example of this? So an example of this would be like, how many hours that a person sleeps each night, and versus how many peanut butter and jelly sandwiches they eat in a year. Okay. If you sleep very little, does that mean you eat a lot of peanut butter and jellies or very little? There's probably not a good relationship. Same thing, if you sleep many hours each day, do you eat a lot of peanut butter and jelly? Maybe you can argue that a person that sleeps a lot is lazy, and so they're going to eat a lot more peanut butter and jellies because that's like, that's what lazy people eat is they make sandwiches. But I don't know, that's kind of a stretch. Okay. So Another is, how much money you spend on gas versus I don't know, how much money you spend on gas versus uh how many books you own, I guess. I don't know. That those two don't really have a relationship, I don't think. Maybe you can argue that they do, but okay, so let's look next on J. So question J. Create a scatter diagram in a U-shaped pattern. Paste the scatter diagram here. Okay. So now, so we can all agree that there's no relationship here, but now take all your dots and move them around to make like a U shape. Okay. All right. So something like that, right? All right. So let's go ahead and copy this one. Okay. Put that here for J. All right. So you'll notice that my correlation coefficient when there's no relationship was close to zero, it was 0.01. My U-shaped pattern is also close to zero, 0.08. Okay. So there's no relationship, but there is a relationship because this curve, if I tried to draw a line through these, I'm not going to be able to draw a straight line, but I can easily draw a curve through here where it hits most of the dots. Okay. So this is an example of a different type of correlation. Now, or a different type of regression, that is. So we're going to be talking about uh, regret stat regression simple linear. This is what we're going to be doing is linear regression for chapter 4. Okay. But there's other types of regression. There's polynomial, multilinear, there's logarithmic, okay? And it depends on what you're trying to model, okay? Now, linear regression is the most common and it's the easiest to understand, and that's the one we're going to stick with in this class. But I want to point out that you don't have just because your correlation is very small doesn't mean that there's no relationship. It just means there's no linear relationship. Okay. So that's the answer here for question K. What does a correlation coefficient close to zero suggest? It means there is no linear relationship. Okay. So that is the answer. But I want to point out that the key word here is that there's no linear. Okay. Um, so uh, I had mentioned before that I actually did a summer internship at the University of Illinois where we studied the aerodynamics of baseball, and we put a motion capture dot on the ball and then put it through a pitching machine so we could measure its trajectory, right? So the thing is that if when that motion capture is capturing those dots for the flight of the ball, it's not going to be a straight line. Balls don't travel in a straight line. When you throw a ball, it curves, right? It's going to, the closest shape that it's going to follow is what's called a parabola. Okay. And so that's the modeling I was doing. I didn't have it like this. I had a baseball trajectory that looked like this, where the ball, went up and then came back down, right? This is what you'd expect to see for a baseball, right? So I can't use a linear regression here. Instead, I would do a polynomial or specifically a quadratic regression, okay? And that would fit very, very well, okay? So another place that you might see something like this is if I was measuring like how much a person eats versus their life expectancy, right? So if you eat very little and you're starving, then you're not going to live very long, right? Your life expectancy would be low and the amount of food you eat would be low. On the other hand, if you eat too much, okay, that's going to lead to obesity and lead to heart disease. And so that again lowers your life expectancy. Okay. So there's kind of a sweet spot in the middle where you eat the right amount, your life expectancy will be higher. Yes. So that would be the kind of shape I would expect to see if I was measuring that. Now, I want to point out that if you're only looking at one side of this curve, right? If I was only looking at like poor countries, and so I'm only looking at this side, these dots right here kind of do make a reasonably good straight line. Or if I was only looking at rich countries, these dots over here kind of make a straight line. So if you're only looking at a certain section of your graph, like for example, if I was trying to model like carbon emissions right now, I don't know what's going to happen in the future. So maybe right now the regression looks linear, but it's actually going to change as time goes on because I don't know what's going to happen in the future. Okay. So anyway, going back over here, the answer for K is no linear relationship. All right, so let's see if anyone has questions. So uh, question, I was about a non-linear relation. So your correlation should be yeah, between 0.3 and 0.0. Yes. So if it's a non-linear relationship, your linear correlation coefficient will be close to 0. Okay. But that doesn't necessarily mean that there isn't a relationship. Okay. Okay. Let's move on to part 4. Is the correlation coefficient resistant? So we're going to hit reset again. So what do we mean by resistant? Resistant, we talked about resistant to outliers. So that's what we're going to test here is how resistant is the linear regression to having outliers. Okay. Okay, so we're gonna hit reset and grab a new scatter diagram of 12 to 15 points with a core. And so in the lower left corner of the applet, draw a scatter diagram of 12 to 15 observations with a correlation coefficient around 0.8. So let's go back over here to StatCrunch. Let's hit reset at the top and we'll get, let's do 13 or 12 points, okay? But instead of having them all over the place, bring them all down here to the lower left for me, okay? Oh, and make sure you hit show, okay? Weird. So that's as close as I'm going to get. All right. So I'm going to put all my dots down here with a correlation coefficient close to 0.8, okay? So I have 0.82. So let's grab that screenshot. And we're going to put that in question L, okay? All right. 0.82. All right. Question M. Add another point in the upper right that roughly lines up with the other points. Okay. I can do that. So if you click somewhere in the upper right, it'll just add a point for you. If you click on this add point thing, you'll have to type in what the value is. So you could type in like 1515 or 20, 20. But if you just click, it'll put a point for you. Okay. So now I've got a new point up there. I'll grab that picture. Okay. All right, and we'll put that in picture M. And yes, I can do that again. Okay, so I want all my dots down here in the lower left where I have a correlation of 0.8. And I'm just going to left click somewhere up in the upper left and it'll just automatically add a dot for me. Okay. So I should have a whole bunch of dots down here in the lower left and one dot in the upper right. Now, is this point right here at the moment an outlier? No, it is not, okay? Because if I wanted to draw a line through the middle of this graph, the line would look like this, okay? And so all of these dots, including this one, are close to that line, okay? So this dot is not yet an outlier, okay? We'll get to that next. All right, so for question M, everything should look beautiful. Question N. All right. Move the additional point around the scatter diagram and note how the correlation coefficient changes. Explain why the correlation coefficient is not a resistant measure. So when we were looking at mean, median, and mode, if I have one outlier that's huge, median doesn't care, okay? Median is very unaffected by outliers, okay? Mean and standard deviation, on the other hand, they are. If you have one outlier, it can really throw things off. So we're going to look and see if linear regression is thrown off by having one outlier. So if we move this dot around and the correlation coefficient changes a little bit, then I would say, oh, it's like median. It's resistant to outliers. But if it changes a lot, it's not. Okay, so let's take a look. So I'm going to left click on this dot in the upper right, and I'm going to move it around. Okay, so I'm going to left click it and drag it. So if I move it off down here, you can see that my correlation is changing. Now it's 0.6. Now it's moderate positive. If I keep moving it down here, now it's 0.24. That's no linear relationship. Okay. If I move the dot over in the upper left over here, 0.19. Like that messes things up a lot. If I put it back in here, now it's 0.82. So just moving this one single dot can really screw up my correlation, okay? So now if I wanted to draw a line through the middle of these points, I still think that the best line is this one right here, okay? But now that dot is way away from the line, so that is an outlier, okay? So that messes everything up. So let's go back over here and answer question N. So explain why the correlation coefficient is not a resistant measure. So we're going to say moving one point around drastically changes the correlation coefficient. This means linear regression is not resistant to outliers. Okay. So just moving one point around can really mess up your correlation. This means that linear regression is not resistant to outliers. Okay. Now, in this situation, so like if I have, I have this point and I put it like way over here, it's clearly messing everything up. Okay. So what do I do in that situation? So, because in the real world, there's always outliers. There's always weird things that happen in your data. And handling those outliers is one of the most important things as a statistician. It's one of the most important skills. And we're not going to dive too deep into it, okay? But if I have an outlier, so first of all, I want to check and find out, like, is this an actual data point? So this number right here is at the point 17 comma 5, okay? So it's possible that someone typoed, they meant to write 17 comma 15. 1715 is right here, okay? Right there. And that's fine. That's not an outlier. That's good, okay? So maybe someone just, when they were typing in their data, typing in their numbers, they made a mistake, Okay. So if that's the case, I need to correct that mistake. Now, another option is maybe this data point right here is an error and I shouldn't include it in my data at all. I should just completely remove it. Okay. That's another possibility. Now, a third possibility is no, this is a legitimate data point. It's accurate and you need to include it in your data. And if that's the case, we need to figure out, okay, then what do I need to do to model this? So it's possible that instead of a linear relationship, I should be doing a different type of relationship. We saw earlier where instead of a straight line, maybe you want to do some kind of polynomial regression or some kind of other type, okay? And maybe that's what's happening. Or there's other options where instead of looking at a mean, we could do what's called a trim mean, where it removes the top and bottom outliers, and that allows you to, get a more accurate picture. Okay. Anyway, we're not necessarily going to dive into that right now because that is the end of our project. So we now want to make sure that we share that and change the restriction to anyone with the link. And we'll copy our link. And we'll come over here to our project. And let's scroll down to the bottom. Oh, let's do a new attempt. All right. And paste our link and submit our assignment to get our confetti. Okay. All right. So there's one more thing I want to talk about before we stop the recording. So I have a data set right here. And this data set is based on attendance. So this is last year's attendance or last semester's. So it's the number of Zoom sessions that a person attended versus their grade. Okay. So I'd love to hear a guess. So we can all kind of agree that the more classes you attend, the higher your grade is probably going to be, right? So if I had to guess what kind of relationship these would have, I would guess that it's positive. More classes should mean a higher grade. But do you think it would be a weak positive, moderate positive, or strong positive? Give me a guess. What do you think? And for those of you who need help, we'll answer more questions in a second. Don't worry, I'm not gonna log off without answering. So Rachel says, Raya says moderate positive. Rachel agrees. Jordan says, yeah. So no one says strong. Come on, come to my class and you're guaranteed to pass, right? No. So if I was to actually graph this out, for chapter 4, we do stat, regression, simple linear. And if I look at my attendance versus people's grades, let's compute that and see what we get. So here's my correlation coefficient, 0.4, which is actually a weak positive. So my class is not effective. It's still positive. The more classes you come to, the more likely you are to pass. But there are other what's called confounding variables, right? Is attending the class the only thing that drives your grade? No, it's not. There's also how much time you spend outside of class. There's how like you might be a really strong at math, and then there's people who, oh my God, I hate math so much, right? So there's other factors that go into it. Okay. Attendance is not the only thing. So here's our dots, and you can see that they're kind of scattered around. I do have some outliers. This one right here, this person attended 3 classes and got an 85%. So the three classes they attended were the first Zoom, the midterm, and the final, right? On the other hand, this outlier down here, this person tried the same attempt to only came to 3 classes and got a 28. So We've got some people who attended a lot and did well, but we also have some down here, like, this person right here. They attended 56 Zoom sessions, but they got a 71. I mean, that's still passing, right? So, um, anyway. Okay, well, that's all I have for tonight. I'm going to stop the Zoom, and then if anyone has any questions, stick around. And if not, then make sure you do your lecture notes before tomorrow's. Cindy's going to cover that material in her class, and I will see you on Thursday, okay?